Hello everybody. In this session, we are going to learn a little bit about sentiment analysis using our Python code. A very basic program, easier to understand and learn and code as well. So here is our Jupyter Notebook. The file is named as sentiment analysis. So what is happening here? I'll explain to you cell by cell. So in the first cell, as you can see, we have a lot of, not a lot of, but a few libraries that are imported. There's pandas and sklearn. These are basically machine learning libraries or data analysis libraries that are widely used within the Python. For any program that is related to machine learning, you will be using these. Matplotlib is to plot your graph or chart or plot whatever you are using or you want to display, as a graph. Then you will use Matplotlib, and Seaborn is also a plotting library. So yeah, you import these libraries, and in the next cell we have this sample data set, a very small data set which contains two types of, you can say, data. One is text, that tells you a little bit about the product. Uh, I love this product, or this terrible, and great service, poor quality, basically four types. And sentiment is like what kind of sentiment is carried with every sentence here, right? So whether it's positive, negative, or what. So here we have only two types of sentiments, whether the product is the whether the sentiment towards the product is positive or negative. So this is the very basic data set. It has like four rows, you can say. And in the next line, I have tried to expand the data set, so make it a little bit bigger. So basically using the same thing, putting some data and sentiment more into that. So if we run this cell, the data is expanded, and you will see the data frame right here. It's not printed, but let me print it. Print df. So as you can see, the data set is a little bit bigger now. It has different sentiments, but almost basically it's repetitive, and you want to run sentiment analysis on top of it. Um, yeah, in the next cell we have this train test split. This function, so what it does, it splits the data set. So here in the train test split function, what we are doing, we are splitting your uh, text data versus sentiment data, and how it does, like, so df text, it represents your feature data basically, right? And df sentiments, it gives you the target data, like what we are trying to achieve, or what basically it's a sentiment data, it's a target data. And it's another column from your data frame. So we are splitting these two using this train test split function. Here we have given the size of zero point 0.2. What it means, like 20% of these data, of this data set, is used for testing, and the variables that are coming out of it are x train, y train, x test, y test. This means that the feature of the text data, the x train contains the feature of the text data, which is which is about the product, like what the whole sentence. The X test contains the feature of the test data. Similarly, for Y train, we have the features of the sentiment data, and Y test, the features of the sentiment data, of the sentiment test data. The next, so we can run this cell, and it will split the test and train data. This can be printed as well, but we don't have to really see that. In the next cell, we are using a function called as counter vector. So if you have used it before, this is the extraction function basically, that converts collection of text documents into a matrix of token counts. and it's very useful as well. So we are running that function and we are vectorizing it, and we are basically forming a xtrain vec and xtest vec, and we can print it actually. So let's see how it looks like after vectorizing. So if we print xtrain vector after running it, um, you can see that, right? It says uh, it gives you in the vector format of the xtrain vector, and similarly it will give you the vector format of x text vector. And right here, yeah, so you see the difference between these two, right? So after we vectorize the data, we are running, like, basically what is happening, we initialize the variable here of count vectorizer, and then in the xtrain vac variable. So what this is doing, vectorizer, like, it transforms into the vector, but what is happening within it, right? uh, it learns the vocabulary of the training data, right? And then transforms the training data into the document term matrix. Each row represents the document from the training data, and each column represents the frequency of a particular word in the document. So that's what it is doing. So it's a little bit about that function. Um, so we have xtrain vector, xtest vector, and we see how it looks like here. Now what we are going to do next, we have this multinomial naive-Bayes classifier. We need certain kind of model or theorem, or you can say algorithm, to run the train and test data on, right? So we have the multinomial naive-Bayes classifier theorem here, or classifier here, and we are initializing the variable, and we are running the fit method. So what actually the fit method do? So the fit method is basically uh, uh, you can say that it's running your model basically. It used to train the model of the given data set. So we have provided, like, we initially divided the whole data set into two parts, like 20% of the trained data and rest is test data. We vectorized it, and now we are running a multinomial NB naive-Bayes classifier on that. Like, we are training the data set on the test data set. So once we do that, you run the training, you trained your model here, and now we predict it, right? Now we say, okay, what are the predictions on my data, right? So that's where we use the predict function. So you run it. It didn't print anything because I didn't put a print statement here. So let's see what's y prediction by underscore pet contains. So if you run it, it will tell you how many, like, it will tell you basically the sentiments of the data, right? Like, there were, if you scroll up and see, we have a lot of these, like, love this product is terrible, things like that. So where after training our data set and running the product prediction on top of it, you'll see that this is the analysis, this is the sentiments, and yeah, and that's what it is. And after that, you can evaluate the model, and check the accuracy score, and print the classification report and everything using these functions. So accuracy score basically tells you how accurate the model is. So if I run this here, it gives you accuracy of 1.0, which is like everybody wants, right? But in large data set, it's not how it works. You hardly get accuracy of 100%. It, like, you get very closer to one, but not 100%. So yeah, I mean, the closer to one is better. But because it's a small data set and a lot of things are repetitive, so that's why it's giving accuracy of one. And the classification report is, it will tell you, like, uh, the precision, the recall, the F1 score, the support, the accuracy, and everything again in this one. So what it means, like, as I told you, accuracy means how accurate the model is, the score of the model. The precision measures the portion of true positives prediction out of all positive predictions. Recall, you can call it as a sensitivity measure out of the true positive predictions. F1 score is the harmonic mean of precision and recall. It provides a single matrix that balances both precision and recall. And support indicates the number of actual occurrences of each class in the dataset. So this is a little bit about the classification report. And we have the weighted average here. We have the accuracy. We have the macro average. So weighted average, it basically it's the average of precision, recall, and F1 score across all the classes, excuse me. And the accuracy provides the overall accuracy of the model across all the classes. So here you see the accuracy is one. So yeah, we have our model, we have our accuracy report, classification report. So every time you run the model, just run this accuracy report, and every time you tweak the model, you will see the changes here, and that's what everybody does in their analysis to make the model more perfect or more closer to 100%. And we have this here, and let's plot it and see how it looks, because pictures, it gives more sense to the numbers. So if we run this, um, it like generate a beautiful plot of positive and negative. We have x-axis on sentiment, y-axis on count. So we have 7 positive counts and 2 negative counts, and yeah, so as you can see, this count plot is a function of SNS, and we use matplotlib to plot this graph. So yeah, this is like very basic of sentiment analysis. We have existing like a lot of machine libraries these days, like from Hugging Face and other major providers are open source libraries as well that you can use directly, and you don't have to write all these lines of code to get this. But this is for more basic understanding of how actually it works. So yeah, that's it. Hope you liked it, and thanks a lot.